Okay. Furthermore, the size of the shadow will depend upon the distance of the source of light and the angle at which the light is falling upon it. Okay. So this distance, okay, and this angle, the angle
Yeah.
at which the light is falling upon that opaque object. As you can see,
Yes.
like it's a natural shadow formation. Like in the afternoon, the shadow size will be very small, while in the
Yes.
morning and in the evening, the length of the shadow will be usually larger because of the different angle at which the sun's rays are falling upon the tree. Getting it?
Yes.
Okay. Furthermore, if the source of light is closer to the object, like you can do one thing, just hold the hold your hand in front of the torch of your smartphone. Okay, now. So if you were
Yes,
to
sir.
hold your hand, as you bring your hand closer to the torch light, so thereby if you were to look at the shadow of your hand on the wall, so thereby its size will tend to increase. Getting it? So the distance also matters here. Closer the object is to the light source, so thereby the size of the shadow will keep on increasing, right?
Sir, when the hand is a long away from the light, the shadow will be tiny.
Yeah, exactly. Okay, no, then in that case it will be tiny. So that is the characteristics of shadow. Another characteristics of the shadow is that um, as you can see, like an opaque screen will be always required to form a shadow. If there is no screen, there will be no formation of shadow. Like if there is no wall, so where will the shadow of your hand be forming? Huh?
Yes, sir.
So a screen will be required, right? A shadow
Yes.
will be casting the shape of the opaque object only. So this shadow casts the shape of this opaque object only and not of the source of light or any other thing,
Source of light.
right? That is one thing.
Yes.
And the size of the shadow varies according to the presence of light coming from different angles, as we have learned. Now, talking about natural shadow formation, talking about like eclipses. So eclipses
Yes.
basically, they're kind of shadow formed, they're kind of natural shadow form when the earth, sun, or moon will be aligned in a straight line. When all of them are aligned in a straight line like this. Okay, now when all of them come together in a straight line like this. So sometime either the moon can come in between the sun and the earth, or sometime the earth might come in between the moon and the
Moon
sun.
and the sun.
Sun,
Sir,
right?
this is when the Earth comes in between Moon and the Sun. That
So
is
this
called lunar eclipse,
that is lunar eclipse. And when the
which will happen at in the night.
good.
And solar eclipse always happens on the daytime, like when
Yeah,
the moon comes in between the sun and the earth.
very good. Okay, now. So as we see in the case of this solar eclipse over here, the moon is in between, right? Getting it?
Yes.
So it's an eclipse that it occurs whenever moon will be passing between the earth and the sun. So thereby it what it does now, it will obscure or it will obstruct the view of the sun on that small part of the earth. Meaning that what happens? Try to understand. These are what happened to this? Hmm. These are the sun's rays. So this much of sun's rays is being blocked by the moon, right? And
Yes, sir.
these suns are not blocked. This is able to fall on the surface of the earth. So thereby there will be a small portion on the earth where a shadow will be cast, where a shadow of the moon will be cast. Getting it now? So that is what a
Yes, sir.
solar eclipse will be. So when the sun, moon, and earth aligns themselves in a straight line, and moon comes in between the earth and the sun, so thereby the shadow of the moon will be cast upon the earth. So this shadow is that of moon and not of earth. Keep that in mind. Okay, now? Getting it?
Yeah.
And when does this phenomena takes place? When it's a new moon day. When it's a New moon day. So on a new moon day, this phenomena happens. On the new moon day, the size of the, you tell me about this, like on the new moon day, what is the size of the moon? Is it very small or is it very big?
Sir, it's small.
On the new moon day, you are saying.
New moon day.
See here. Think about this again.
Sir, it's small, right?
It's a small, yeah. Right. And after this, it keeps on increasing. Right.
Yes.
Actually, the thing is, no, it's the opposite. The moon is biggest in on the new moon day. The size of the moon is biggest on the new moon day. Is it true or false? Think about this once again. Usually what happens, you on the new moon day, we are not able to see the moon properly now because it's a small.
Yeah.
After the new moon day, the size of the moon keeps on increasing. Getting it? So this phenomena of
Yes,
solar eclipse will be on the new moon day usually. So hope you have understood this.
Happening on the new moon.
Right. Talking about
Yes,
the
sir.
lunar eclipse. So talking about the lunar eclipse. So in this, what happens? The earth will come in between the sun and the moon.
Moon.
So here what happens? All the sun's rays that is falling upon this, it falls upon this earth, right? And thereby on that day, the moon will not be visible at all, right? So when the sun, the moon and the earth aligns in a straight line and earth comes in middle of the two, so thereby the shadow of the earth is casted upon this moon. So this region that you see over here, now hope you can look over here. See this part. This is the shadow,
Yes,
right?
sir.
And it is because of the shadow of the earth will be casted upon the moon also, right? So that is called as lunar eclipse, right? And the total lunar eclipse will be formed in the regions of the moon where the earth's umbra falls, whereas the partial lunar eclipse is formed where the earth's penumbra falls. These terms are really not important, but you'll be understanding about that in geography in detail. The general thing is that the earth's shadow will be casted upon the moon in the lunar eclipse. So hope that is clear, right? So a question is that when lunar eclipse occurs, when does it occur? So it will occur during a when it will occur during a full moon, right? Now it will occur on a full moon. Getting it? So when
Yes, sir.
it's a full moon, then
So,
usually the
sir,
lunar eclipse
lunar
occurs.
eclipse. Lunar eclipse occurs when it is full moon, and solar eclipse occurs when it is the new moon day, right?
When it's a new moon, exactly, right? Now, so that is one thing which we have. Okay. Okay. We did learn about laws of reflection of light in the previous class. We have learned about this, right?
Yes.
Learned about types of reflection, and in the previous class we were learning about left and right inversion of the image, right?
Yeah.
So this is something which we have learned. Like in reality, this boy has raised his right hand, but in the mirror it appears as if he has written his left hand. Okay, now. So this is the left hand of the image right now. Talking about the image, that is the left hand of the image right now. But in reality, the person has risen his right hand. So it's left right inversion of the image is observed here. So that is called as lateral inversion.
Lateral inversion.
Good. So hope that is clear to you. Okay, no?
Yes, sir.
After this, you would be learning about, like, talking about this also, as we learned in the previous class, like the word ambulance, why it would be painted in the left right inverted direction, so that the vehicles that are in front of this can view it properly right now. And the image formed by the mirror is always left right inverted. Particularly the image formed by the plane mirror is always left right inverted. Okay, now. So it basically means that the left side, the right side will appear as left, or the left side will appear as right. So this hand will appear as right now. this hand.
Yes, sir.
That is one thing. The main thing today today we would be learning about the concept of pinhole camera. Okay, now we would be learning about concept of pinhole camera. Okay. So pinhole camera, it's a simple camera which does not have a lens. Okay, na? Usually a camera has a lens in it, right? But
Yeah.
usually this pinhole camera, it does not have a lens, right? So if you were to look at the
Yes.
structure of this pinhole camera now, if you were to look at the structure, it will be kind of like this.
Sir, pinhole camera is a simple camera without lens and with a single small aperture.
Aperture. Very good. So say we have taken a small box over here, right? And by the way, you
Yeah.
yourself can make this. So say there's a tree somewhere, okay, like this. And you have taken a small box like this.
Sir, in the pinhole camera, image will be blurred and not clear.
Yes.
Sir, in pinhole camera, the image will be blurred and not clear.
Yeah, the image will be blurred, it will not be clear, and it will be diminished in size,
And
it will be inverted.
this
Okay.
process is called rectilinear propagation of light.
Rectilinear propagation of light. Very good. See, so basically what happens, these light rays coming from the tree will be passing via a very small hole into this box. Okay, now so we have taken a box, and this box have been tightly packed so that there is no hole in this from where light can enter except for this hole. Okay, now and this hole is basically being called as pinhole. Right now, that is being called as pinhole, and that makes up a very small aperture. So as the light rays will be incident of light rays coming from the tree will go inside this dark box. So thereby an inverted image of the tree will be formed. An inverted image of the tree is formed. So the image form over here is inverted, it is diminished, and it is blur. Okay, it is blurry. Yes, Halima. I
Yes,
think you're
sir.
having some network issue today, no?
Yeah.
Okay. See what we learned about the concept of the pinhole camera right now. That pinhole camera would be basically a very simple kind of camera. It does not have a lens, so it just makes use of a very tiny opening in this. So that is the size of the opening in this dark box is similar to that of a pinhole, right now. So using this, all the light rays coming from this plant is focused. It is focused on a very small area inside this, right now. And basically we try to obtain an image as clear as possible, right? And the image formed by using this pinhole camera will be always inverted, always smaller than the object and always inverted. Getting the basic concept?
Sir, can you repeat?
Yeah. What I just said, that this pinhole camera, it has a very simple structure, right? And using this pinhole camera, what basically is being done over here, the light rays that comes from this tree, for example, the light rays that comes from this, it is made to pass through a very small hole, and all the light rays are being focused on a very small area inside this box, and on that small
Yes.
area of the box the formation of image takes place, and that image will always be inverted, upside
Yes,
down.
sir.
right now.
Yeah.
So that is the concept. And this pinhole camera, it's a not a very new concept, right? It was first used in the year 1000 AD. Okay, now getting it. So almost about 1000 years ago it was used. Getting it now. So that is the concept of pinhole camera. So it is a light tight box. Light tight box. Why we say so? Because light cannot enter into it apart from this pinhole. Light cannot enter from any other source. Right now. By the way, this screen over which the image formation takes place now, we use a special film on this. Okay, now a special screen is used to obtain the image. Right now.
Yes.
That is the concept over here. So hope you have understood the
Yes, sir.
basic concept, right? Furthermore, the image formation that takes place in the pinhole camera, it's a proof of rectilinear propagation of light. So what does the rectilinear propagation of light says that? It says that light travels in a straight line. Getting it?
Yes, sir.
So that is what the concept
Sir,
of
we have learned in the last concept that light travels in a straight line for
exactly.
the candle.
Exactly right now. So where we had raised certain wooden blocks with holes made at equal distance, right? Like
Yes.
this was the candle. We had risen some wooden blocks over this, right? So if the hole were made to be at this place, thereby on the other side, we won't be able to look at it. Getting it?
Yeah.
The light comes like this. It will be obstructed from this. So hole have to be made at this point. So that proves the
Yes.
rectilinear propagation of light, right? And in this pinhole camera also, we have learned the same thing, that light comes in or comes into this via a very small opening, right? Now there are some
Yes,
important
sir.
concept, important some important concepts in this. See, if the distance between the object and the pinhole is increased, that is basically if the object is moved away from this pinhole camera, the size of the image form, the size of the image form on this screen, it will decrease. Getting what I'm trying to say? So as the distance
Sir,
between the
it will
tree,
increase and it will
it will
decrease
decrease.
um, and the image will be more blur.
More blur, right now. So this
Yes.
pinhole camera that is working on the principle of rectilinear propagation of light, it is a very good demonstration to show that show how light forms images of objects. Getting it now? So if light were not to travel in a straight line, will the image formation take place in this? No. Right now. So it is that
No, sir.
light rays from this tree were traveling in a straight line. If it were to be traveling like this, so you would have placed the box over, you'd have placed the pinhole camera over here. Say that this is pinhole camera. Okay, Halima? ये pinhole camera hai. So
Yes.
the light is, if it does not travel in a straight line, but rather a zigzag direction. So it will go from here to here. It will go into a
Yes.
different direction. So it travels in a exactly straight direction. That's why image formation takes place. Okay, now?
Yeah. Okay,
So
sir.
that is the proof of rectilinear propagation. That is one thing which we have learned. Another thing, as I was saying to you, that as we increase the distance between the object and the pinhole camera, the size of the image will decrease. Okay. So upside down inverted images will be formed right now. And furthermore,
Yeah.
the images formed using the pinhole camera will be smaller in size. In every case, it will be smaller and it is real.
It will
Why?
be yeah. It will be real, but
Because
it
it
will be inverted and smaller in size.
smaller in size. Why do we call this image as real? Because it can be obtained on a screen right now. Like our
Yeah.
image that forms in a plane mirror, it's not a real image but a virtual image because you cannot obtain it on a screen. Getting what
Yeah.
I'm trying to say? So the image formed by pinhole camera will be real because actually the image formation is taking place on a screen. Getting it?
Yeah.
That is one thing. Another factor, 1 minute. Another factor is important thing is that if the distance between the object
If the distance between the object and the pinhole camera
increases, then size of image
will decrease.
will decrease. Very good. That is another important concept. Okay. Now, here are the following steps using which we can also make a pinhole camera, right? So how to make pinhole
Yeah.
camera? We can simply take um, cardboard boxes, right? So we can take two cardboard boxes, one larger than the other, such that box slides into the other without any gap, meaning that you'd be taking different cardboard boxes basically. Right now, you have to take two cardboard boxes. One has to be bigger, another one has to be smaller. Okay, now this one,
Yes.
and take another one of such a size that it can easily slide into the bigger one without leaving any gap. Like if you can look at this in this image, we have taken two cardboard boxes,
Yes.
this one and this one. So the another one is just
Yeah.
slightly smaller than the bigger one, not very small but slightly smaller. Okay,
So there is no gap.
there is no gap between it. Okay, now cut out
Yeah.
open one side of each box. Okay, now and on opposite side of the larger box, cut a small hole in the center. So what we have done, we
Yeah.
have cut out the ends of both of the boxes. What we have done, this end of one box and another end of this box will also be cut down. And this is not a cut in this that you see over now. The image, the diagram is such that so that we can see this pinhole. Okay, now this structure, that this part of the box that you see now, it may look like it is cut, but it is actually not cut. So that we are able to
Yes.
see this pinhole camera, it has been left open, it has been shown as open, but in reality is it is not open. Okay, so
It
the
is
back,
not open.
yeah, so the opposite side of larger box of both the boxes have been cut down. Okay, now on the opposite side
Yeah.
of the larger box, cut a small hole in the center. So over here what we're going to do, say that this one is a small, larger box, so cut a small hole in the center, right? Now, on the opposite
Yes.
side of the small box, cut a square of about 5 centimeter and cover this area with a tracing paper. So what we have done now,
Sir,
see,
tracing paper means a butter paper, right?
yeah, tracing paper, butter paper, same thing. Okay, now, see this part was already open now. The one that I'm going to highlight, this was open.
Yeah.
You can think of this why this was open, because it has to be fitted into the larger box. Now this one has to fit under this. Okay, now, so this
Yes.
one is left open. Now on the opposite side, meaning that on this side now, we have cut a small square. So this much of area from the opposite
That
side.
that will be the screen.
Exactly. That will make up the screen. So we will take it out. We will cut it out. Okay. And we will cover this open area with a tracing paper, right? After having done
Yeah.
all this, you're done pasting a tracing paper over this. Now slide this into the larger box. Okay, now so
Yeah.
slide the smaller box inside the larger box in such a manner that the side with the tracing paper is on the inside. Okay, now getting it so far? Like have a look
Yes,
at
sir.
this diagram, that should give you a better clarity. So the side that will be having a tracing paper, that is on the outside, not in the inside. As you can look
Mm.
over here also. Okay, now getting
Yes.
it so far? Good. Now cover the camera and your head with a black cloth. Cover the camera and your head also. Like basically you have to take a black cloth and cover the camera and yourself also. And then get ready to observe the distant objects. So you can place it near to the lights, any source of light, and you will observe that the light will be, image will be formed on this screen. Getting it so far? Is this
Yes, sir.
concept clear to you? So in this manner, you can make a pinhole camera. Okay, now we have some examples of natural pinhole camera also. Example of natural pinhole camera also, like sometime if you happen to walk on a street, so thereby also you can see the images of leaves being formed. Hmm. As we see that there are spaces between the leaves of the tree, right?
Yeah.
So those spaces between the leaves of the tree will be kind of forming a image of the sun on the flat ground. Hmm. If I can show it to you over here, this is the image actually I'm referring to you. Like many times you happen to walk on the street and thereby you can show oval shaped images on the ground, oval shaped light images on the ground. Not this one. No, not this one. Not able to get it. Just give me a minute, okay? Now.
Yes, sir.
Yes, Salima, have a look at this. See, these are examples of natural pinhole camera. Okay, now. So when we pass under
Yes,
a
sir.
tree covered with large number of trees, so we notice some small patches of sunlight under it, like this.
Sir,
So
it is like the
hmm, it is like the pinhole images of the sun. Okay, na? These are the
yes.
like pinhole images of the sun, that the one that is over here. So these are the natural pinhole camera. Okay, na? So the
Okay.
gaps between the leaves of the tree, though they act as pinhole, and via that the image is formed. Hope you are getting it. Okay, na? Hope you have understood this. Okay.
Yes, sir.
So that is the thing. So here we have learned about various concepts in the chapter. If you have any doubt in any concept, please let me know, or else we can do some questions from the chapter. Yeah.
Sir, can we do some questions?
Yeah, sure. Okay, now I'm going to name few objects. You have to classify them, whether they are going to cast a shadow or whether they are not. Okay, now.
Yeah.
So talking about a pencil, will it be able to cast a shadow?
Sir, yes.
Okay. Paper.
Paper, yes, sir.
Okay. Shadow cast by it. We have to tell the nature of the shadow also. So the nature of the shadow cast by pencil will be dark, right?
Yeah.
Paper will also form a dark shadow.
Yeah.
Okay. What about water? Water, will it form any shadow?
Uh, no.
No shadow. Okay. Do tell me, what about butter paper? Will it cast any shadow?
Sir, butter paper,
Hmm.
yes, sir.
Yes, but will it be very dark?
No. Light.
Light shadow will be cast upon. So what we observe, that translucent objects cast a light shadow. Okay, now.
Yes.
So translucent objects cast faint shadows. Okay, now, because they partially blocks the light. Now they blocks the light partially. Okay.
They block, but
Hmm.
a bit.
A bit,
Partial.
or we say partially block the light. Okay, no? Okay.
Yeah.
Do tell me, this is something which we haven't learned, but I think you would be able to answer this. There was a instrument that we used in the earlier days to measure the time, and that basically used to cast the shadow. So by looking at the position of the shadow cast by that instrument, we were able to measure the time of the day. You understood
Sir,
my question? Hmm?
sir, can you repeat?
See, there was an instrument that measures the time of the day by the position of the shadow of an object cast by the sun. My question is that there was an instrument that we used to measure the time of the day.
Hmm.
How? By looking at the position of the shadow of an object that was cast, by looking at the position of the shadow cast by the sun. See, that was sundial actually. Okay, no? The sundial that you see over here. Okay. So by
Uh,
looking at the position of the shadow, we were able to tell what time of the day it is. Okay, na? That is one
yes.
thing which we have done. Okay, good. Okay, do tell me what are the two types of reflection?
Sir, the two.
Hmm.
Sir, you are saying about the reflection, right?
Yeah, what are the two types of reflection?
Um,
Yes.
sir, 1 minute.
Okay, can think about it.
Sir, I mean, sorry. Reflection is,
Didn't we learned about
sir, regular reflection and irregular reflection.
exactly regular and irregular reflection? Very good. Okay, do tell me, is there any color of the shadow?
No, sir.
Shadow doesn't have any color. Good. Okay. Do tell me that do tell me in order to observe a shadow, what are the necessary conditions?
Sir, can you repeat?
In order to form a shadow, what are the necessary conditions required? Do we need, out of the following options, do tell me which conditions are required, which are necessary to observe a shadow, which are necessary. So is it
Sir,
light?
you're not sharing a screen.
Is it not visible to you?
No, sir.
Okay, just 1 minute. Now it should be visible. Hmm.
Yes.
Yeah, the question is that what are necessary condition for shadow formation?
Necessary condition for shadow formation.
Hmm. The options are light or screen or opaque object, or the third one is all of them.
Sir, light, screen. Sir, all of them.
All of them. Very good. Okay, do tell me, I'm naming few objects. You have to tell me which of them will form a circular shadow. Okay, now? So circular shadow, will it be formed by a ball? Will it be
Hmm.
formed by a flat disc? Or will it be formed by a shoebox? Hmm? Or an ice cream cone?
Sir,
So which one of them will cast a circular shadow? Yes.
a ball and a flat disc.
No, only one of them has to be true.
Oh,
Yeah, think about it.
sir, a ball.
A ball will cast a circular shadow. Good. Very good. Okay. I'm going to draw one image. Okay, now you have to tell me uh, how this image will be formed on a screen. Okay. On a pinhole camera, you have to tell me. Okay, now.
Okay.
Like this. So that is the given diagram. So you have to tell me on a pinhole camera how the image of this given object will be formed. Okay, I'm going to draw some diagram over here.
Yes,
So
sir.
do tell me, will it be formed like this? Or in the second image, do tell me, will it be formed in this manner? Or do tell me, will it be formed like this? Hope you can understand the diagram, okay? Or will it be
Yeah.
formed like this?
Sir,
Yes.
sir, the answer is
Yes. Think about it carefully. Recall the
sir,
property first of all. B.
no, B.
D, you're saying.
Yes.
Very good. That is correct. Okay, no? So that is how image will be formed in a pinhole camera. Okay. Now I'm going to give you one more question. Just 1 minute. Do tell me that on a diagram, let us say I have taken a flower. Okay. So there's a flower which is made on a colored on a paper, and it has been pasted on a transparent glass sheet. Okay, try to understand the question. There's a flower. Let me write the question actually. A flower made of thick colored paper has been painted or has been pasted, I mean to say, has been pasted on the transparent glass sheet. So this is a transparent glass sheet actually. ये एक transparent glass sheet है. This is a transparent glass. Okay.
Glass sheet.
And over this, we have pasted the image of a flower that is made on a piece of
Thick
paper.
colored
Okay.
paper.
Thick color paper. Okay. So from here, you are projecting light on this.
Yeah.
From here, you are projecting light on this. So the light will be falling upon this. Okay. Light will fall
Yes.
upon this. Now on the other side, you have a screen also.
Yes.
That is your screen. Okay. So the question is that to tell me what will be the shape and color of the shadow seen on this screen? What will be the shape and shadow of the flower formed on this screen? Halima, have you understood this question?
Yes, sir.
Good. So answer the question.
Sir, this flower made up of thick colored paper has been placed to the point. Mm,
What will be the shape? What will be the size of the shadow formed on the screen?
sir, the size will be big and the shape will remain the same.
The shape will be same. Okay.
The size will be big.
Okay.
and there will be no color.
There will be
I
no
mean,
color. The
yeah,
shadow will be basically black, right?
yeah,
Good. So the shadow of the image form will be basically black, right? And the shape would be similar, but the size will vary. Okay, now
yeah,
size will vary, but the shape will be basically
similar.
same. Good. So hope you have understood this basic question. Okay.
Yes, sir.
Now from the chapter, there are some other things also which I would like to ask from you. Like, do tell me mm, that the speed of the light will be maximum in glass or in water or in air or in vacuum. In which it will be maximum?
Sir, what?
The speed of the light will be maximum in which medium?
Uh,
In which substance it will be
Sir,
maximum?
vacuum.
In the vacuum, it will be maximum. Very good.
Yes.
Okay, do tell me, on the basis of whether an object emits their own light or not, what are the two types of objects we have? Whether an object emits their own light or not, what are the two types of objects which we have? We have
Uh,
hmm,
Sir, luminous and non-luminous.
luminous and non-luminous. Very good. Okay, so that's it for today, Halima. We'll be continuing from the next one. In the chapter, we have finished this chapter. Okay, now? If you have got any
Okay.
worksheets from this chapter or questions from your book, you can